Types of solids. So solids can be crystalline, meaning they have order to their atoms or molecules, or they can be amorphous, having no long-range order. We can take the crystalline solids, the one with order, and divide them into three more categories: molecular, ionic, and atom. And that's based on what are the particles that are composing that solid. So crystalline solids. Molecular solids are composed of molecules. They're going to have low melting points because the only thing that's holding those molecules together are the intermolecular forces. Ionic solids have composite units that are formula units of ions, cations and anions. What holds these together are ionic bonds, the attraction between positive and negative charges. This is way stronger than the dipole forces or even hydrogen bonding that we've been talking about, because here it's not a partial charge, it's an actual charge. +1 and -1, or +2 and -2. So these tend to have very high melting points. Atomic solids are composed of atoms. The thing that holds the atoms together is just dispersion forces. You can't have a polar atom, so it's only dispersion forces. Larger atoms are going to have stronger forces holding them together. They'll tend to have higher melting points. Others, the smaller ones, will have lower. So the melting points here are quite varied. Talked about that. Talked about that. Talked about that. Taking one of those group, atomic solids, and we can subdivide this into more categories. Isn't this awesome? Just all the categories. We do this in our everyday lives, and we're okay with it. Some people sort their socks. Other people put all their clothes in a pile on the floor. People like that in my house. Atomic solids. Okay, so we divide these into categories based on what's holding the things together. There are covalent atomic solids, where the atoms are held together by covalent bonds. These are going to have high melting points. So silicon is an example of this. The silicon atoms are actually covalently bonded to each other. So a chunk of silicon is actually just one ginormous molecule. Diamonds are like this. The carbon atoms are covalently bonded to each other. A diamond is one giant molecule. Graphite is also a covalent atomic solid. There are non-bonding atomic solids. These are only held together by dispersion forces. These are going to have very low melting points. The only things that have formed non-bonding atomic solids are the noble gases. All that interacts, all that pulls them together are the dispersion forces, and that only happens at really, really low temperatures. And then there are metallic atomic solids. So in a metal, you have individual atoms, but they're not held together by dispersion forces or covalent bonds. They're held together by metallic bonds. They are also going to have varying melting points, but most metals melt at relatively high temperatures. Obviously, an exception is mercury, and I think it's gallium. Gallium's the other fun one. It melts slightly above body temperature. So at room temperature, it's a solid, but you put it in your hand and it'll melt. You can read that. Here's a picture of a diamond and an illustration. The diamond and the carbon atoms are bonded together. What makes a diamond different from the graphite in your pencil is that the way that these are bonded together is different. Non-bonding, metallic. A metallic bond, the picture, yeah, here it is. So the metallic bond, this is a little hard to understand. This is the electron C model. So in the metals, the electrons are held fairly loosely. This is why metals often form cations. They'll lose an electron. So here is a metal atom. It hasn't lost its electron, but it's held pretty loosely. And so I think of this as, here's a bunch of houses, mom's home, and the electrons are the little boys again, and they send the little boys out to play. Now the electrons are going to stay in the neighborhood, but they're going to move around. They're not going to stay right next to their own house. And the metallic bond is the attraction of this group of electrons that are swimming around, a sea of electrons, for the positively charged nuclei of the individual atoms. And that's the metallic bond. So what do you need to be able to do with that? Well, something like this. Identify each solid as molecular, ionic, or atomic. You can use your knowledge of nomenclature to help you with this. NH3. Is nitrogen a metal? No. Is hydrogen a metal? Nope. Two nonmetals, it's a molecular compound. Is it a molecular solid? Yep, it has molecules. So this is a molecular solid. This is one of those things that students sometimes make too hard. You overthink it. How about this one? Calcium and oxygen. What kind of a compound is it? Ionic. If it's an ionic compound, it's an ionic solid. How about this one? Krypton. That's atomic. It's an element all by itself. It's an atomic solid. If we did iron. Iron is also an atomic solid. Okay. Any questions?